You probably own a smartphone and use it to browse the web, have a bunch of favorite apps, and think you understand how everyone uses their phone. But you're probably wrong. We're bad at self-reporting, and there's much rumor and misunderstanding out there. I've been designing for mobile since 1999, and today I want to share my observations, and especially those based on actual research, so you can build products the right way for everyone. I'm going to talk to you about a lot of things. First, much about the basics, technology, and physiology. But then I'll give you some key human behaviors and how to take advantage of them to design better touch experiences. The normal computer is no longer a desktop with a keyboard and mouse, but a touchscreen, smartphone, or tablet. And that's great. Touch is so natural that it's a snap to use and design such systems. Touch is so natural, anyone can design a touch-based system without the risk of users hitting the wrong target or anything. Really, trading scroll and select, or the mouse, for touch means we've just ended up with a new set of interaction problems, and more intractable ones for now, because touch is still very new. We're still developing patterns of interaction, and we don't really, in general, understand how touchscreens even work. All too often we make decisions based on anecdote, opinion, personal bias, hearsay, and a rumor. What we used to know about touch was what Apple told us, the 44-pixel target. And before that, those that paid attention to touch then simply knew that touch targets had to be 22 millimeters wide to accommodate finger sizes. International standards say so, and they're always right. Right? We know now that despite writing more books than me, Josh Clark's reach charts, shown here, have no basis in reality. Not everyone is one-handed, and not all phones are used in portrait. And thumbs just don't stretch. I mean, come on. This is something Luke Wroblewski put up with a caption, "Still think that back button belongs in the upper left corner of your iPad app?" I mean, really, does anyone hold a tablet with one hand and try to tap? At all, much less the new crop of very large tablets shown here. I think we can safely say no. But we don't have to think what we know. All too often we make decisions based on gut instinct, or technical convenience, or misunderstanding of psychology, or physiology, or misapplying old technology to new situations. But we're scientists. Remember how we hate being confused with UI designers, or even worse, artists? Because we don't just go with opinion. We base our decisions on information, on user behavior, on science. So a couple years ago I started researching this again. I couldn't find what I wanted, so I started with a clipboard and observed over 1,300 people on the street, the train and bus, in coffee shops and so on, in several countries, using their phones. I did meta-research, reading dozens of reports on touch and gesture, and finding 19, then, with good enough data to actually pull in, normalize, and correlate to my own. All of these agreed with each other, by the way. My favorite one of them had over 120 million recorded touch events. So this is sometimes very statistically valid stuff. In concert with the e-learning guild, I got another 651 observations in schools, offices, and homes, adding more data on tablets and reconfirming our data on phone use. And more recently, I did a combined intercept and remote unmoderated test to get data on how people use touch-based, on types of input, and tasks they're trying to perform. And now others are doing research to carry this on. We're getting usage data from other countries, from other device types, gathered in different ways, and as people do things like carry around their shopping. We have the data, and now we need to apply it. We know how to design for people, and for the many devices people use, not just iPhones and iPads. We know how to design for hands, fingers, and thumbs. Let me talk to you about technology for a bit, so you have a good understanding of the basics before we move on. Before touch, and actually before the mouse, there were pens, or the stylus if you prefer. The use method is similar, and today all touchscreens can use a stylus, but we tend to focus on the primary use case, fingers and thumbs. Early stylus systems were called light pens. Here in the first production applications, the Sage system for the US Air Force, it was actually gun-shaped at first. The pen is actually a reader closely coupled to the timing of the display, so it can tell what part of the screen it's looking at. For those from that era, like me, the duck hunt gun used the same principle. If it saw the target encoding, it knew it was pointed the right way. By the late 1960s, light pens had come down to pen-sized, and were usable on reasonably modern-looking systems to do tasks we're familiar with: point, select, copy, paste, gesture, etc. There are a number of other pen-based systems and some other low-use touch technologies I'm going to skip here. If you're old enough, one of the first touch screens you may have used is on an ATM, or a public device like a museum kiosk. These first came about in the 1980s, and used a grid of IR beams, or lasers, to detect the position of your finger. Really, though, they detect anything on the screen, and used some simple human factors practices to keep stuff away, like insetting the screen a lot. This was actually automatic, as the sensors took a lot of room around the bezel anyway. The beams were coarse and detected your whole finger, so I had to calculate the center. Buttons had to be big because of this, but it worked for the applications it was used on. Remember all this, I'm going to come back to it in a minute. When touch really started being useful was when resistive touch came about. Resistive is the one where you have to simply apply pressure and a grid of conductive leads makes contact, which means electrical contact, and various electronic trickery means the device knows about where you touched. Additional math lets it determine pretty precisely where you, or the pen or whatever, touched. These are still being built, even for consumer devices like tablets or seatback entertainment systems in airplanes. They can be very responsive and high precision, but there's a trade-off, as there is with everything. The flexible top layer trades responsiveness for ruggedness. Since they don't use glass or something rigid as the top layer, they're often used for rough environments like pin pads or aircraft systems. But then they tend to pick thicker top layers and get a reputation for being hard to use. You then use a ballpoint pen or something to push harder, and they get scratched up and hard to see through too. For the rest of this deck, when we talk about touch, we're going to mean capacitive touch. That's what's used on absolutely all mobile phones, tablets, and increasingly everything else remotely small and touchy these days. Computers, cars, everything. Capacitive touch uses electrical properties of your body. Your finger acts as a capacitor whose presence in the system can easily be measured by those little nodes in a grid on several layers between the display screen and the protective plastic or glass. One layer on the x-axis, one on the y, so now the diagram of the layers of the resistive screen doesn't seem so bad. And this diagram here is simplified. There are other layers in there for glare reduction, insulation, and so forth. You can actually see the capacitive touch sensors sometimes. Rarely is the whole grid, and only one direction at a time. Has to do with polarity, maybe? This is important so you understand the previous slides. Those sensors aren't microscopic, but quite large. So how do you touch something small between the lines, then? Well, there's a lot of math to estimate where you touch between sensors. If someone ever refers to the touch sensor chip or chipset, they aren't kidding. Until integrated very recently onto things like phones, there are whole sets of processors just to figure out where you touched. This is a current processor for larger and unlimited touch systems. Not dual touch, but unlimited for collaborative large screen use. This isn't a magical perfect system. There's math and interference and the same trade-offs I mentioned before in thickness, weight, cost, and optical clarity get in the way of increased precision. If you add too much precision, or can sense, say, small pen tips, ambient electrical noise gets overwhelming and it's hard to use your phone in the real world at all. You can actually see how inaccurate these systems get. A few years ago, Motorola put a handful of devices into little jigs so they could precisely, robotically control the pressure, angle, and speed of touch sensing. This is an example of some of their results. Even the much-loved and perfect, everyone says, iPhone is quite imperfect, with notable distortion at the edges, and actually a total inability to get to the edge on some sides. Check out the stair-step pattern on the Droid. That's a problem with the calculations or something that predicts the precise position between the sensors. The pitch of the steps is the sensor grid size. Don't think this is just an old phones issue. No phones are perfect, even now. Try it yourself. Get a ruler, a stylus, and a drawing program. Even with the newest high-end phones, there are issues. Diagonals are best to test with, and you'll see little waves and swoops at the edge of the screen still. Speaking of a stylus, let's talk about contact patches. Old ISO standards, and people trying to use logic to figure out touch targets, talk about the size of fingers a lot. So this distance between the arrows is critical. But is it? Well, for old IR beam systems, sure. They shot light beams or lasers that saw your whole finger. Had less processing to find the center, so had to work off that. But it's not important how big our fingers are. The finger squishes against the screen, and only a small part gets flattened and detected by the screen. So my own research indicates contact patches are pretty much the same for everyone. Children press really hard, so have a larger relative contact patch, for example. People also use their fingers in different ways, deliberately. They slow down and use fingerprint tips to get more precision. There's some variability based on task, so people can use fingertips and press lightly, but that doesn't actually make them that much more accurate. It's best to assume the device cannot sense how big your finger is, how hard you pressed, how big the contact area is, which way it's facing, or anything else. All it gets is a point that it assigns to be the touched coordinates. This is a good, safe assumption, but if you're making a drawing tool, go ahead and look harder. There are pressure sensing values in the OS. New screen technologies use the same sensing methods to pick up the whole touched area, and if everything goes well, you get size, which you can translate to pressure. Not all devices do this, and by no means does everything go well on those that do. Shown here is a reliable program on a brand new Nexus 5X, and it sorta worked after a fashion to get this, but not as advertised. Use anything like pressure sensing carefully and very rarely. Force Touch and 3D Touch are specialized implementations. I have no actual research on them, either. I have general fears about their value, which we can discuss if you're interested, but we'll see how much it's actually adopted and used. Since we're sort of in the history section, I should also mention it's not new. Others have combined physical sensors behind the screen, and were roundly mocked for it. Must be nice to be Apple and get away with this stuff. And there's lots of cool stuff happening with other sensing techniques, especially remote control kinesthetics. If you ever work on a large wall-mounted display or other such interactive system, ask me about this. I've codified a set of ways those can work and some guidelines to design for them in concert with a maker of such systems. But that's for later. And maybe for mobiles sometime soon. Because this phone and all smartphones are not just about touch. They have a huge number of sensors that make them aware of the user and the world they live in. Don't just think that touch is the key thing mobiles do. And if you get a design to OS level stuff or games or anything else cutting edge, think about using these sensors for interaction. Cameras are used to turn the screen on and off, to tell where you're reading on some devices. The pressure-sensitive touchscreens like Apple 3D Touch are not part of the touchscreen using magic, but a totally different sensor behind the screen. Accelerometers can get much useful data about the user's context, as can speakers and microphones once we get past people being fearful of being spied on. So we've had touch technology since at least the 1980s. Why did it take so long to become a big thing? Why, really, does everyone think Apple invented touchscreens? Today, everyone has a mobile. There are more mobile phones than humans. In 2014, more than 1 billion Android devices were activated. Smartphones are 3/4 of all new mobiles sold, and it's approaching half of all devices in use. The desktop installed base is dropping. So as I said, the normal computer for most people is now a handheld, touchscreen computer, not a mouse and keyboard. So how did consumer mass-market touchscreens in the 80s, like this car dash control, still working in 2015 no less, putter along and get minimal traction until another quarter century passed? Because we're slow to adopt technologies. The first mobile networks were launched in 1946, applying the technology from World War II and taking advantage of the post-war appetite for new things and a better life. A demonstration project put cellular phones on trains starting back in 1969. So why did it take another 14 years before we could carry our phones around with us? Sure, a little bit of technology maturation, some short-sighted regulation by the FCC, but in large measure, I think this is a broader cultural issue too. Many like to say it took the brilliance of Apple or it's because the technology wasn't good enough, but I actually used PDAs and older smartphones. They weren't bad. It just takes time to get people to understand how technology works and how new technologies benefit them. In the 1980s and 90s, the feature phone and the PDA were the technologies that people were comfortable buying and using. And these were products that, for the most part, didn't disappoint their manufacturers. People got rich and famous off this work. PDAs became indispensable to a large part of the working population in the West. But today they are largely forgotten with the overwhelming success of modern smartphones. We hear much about the digital native, people belonging to a younger generation that have grown up using computers, game consoles, and increasingly smartphones and tablets. But I dismiss the premise that early exposure fosters deeper comprehension of the technology. and that societal issues that arise from its use. We should apply this designation more simply. Like the pre-industrial farmer, the digital native learns through ritual, myth, and societal pressure. There's little to indicate that these users, or any users, deeply understand the technology of smartphones or could apply their understanding of it in other cases, or that it would result in their making good policy decisions. This is also why I try to avoid prognostication. The next big thing relies less on technology than society's willingness to embrace the technology. We like to think of systems as computers and networks and wires and software and data stores piled on top of each other. But there's little point in building a system if people are not part of it. And if you think it's hard to change a database or API, try changing how people work with your system. We often forget that, because people live in the real world, their interactions with devices occur in the layer where we convert reality into flat representations of input and output. Everyone assumes that all phones are still small iPhones, grasped with one hand and then tapped with the thumb. What do you know about your thumb? Physiologically, your thumb includes the bones that extend all the way down to your wrist. Plus, the thumb's joints, tendons, and muscles interact with your other digits, especially the position of your index finger. If your fingers are grasping a handset, there's a more limited range of motion available to the thumb. Moving your fingers lets you change the area your thumb can reach. Bending is important because while the free range of the thumb's movement is in three-dimensional space, touchscreens are flat, so a limited part of the thumb's range of movement gets mapped to the phone's screen. So this widely distributed chart is impossible. It's just not how thumbs work. Try to trace those edges sometime on your phone. My thumb makes popping noises and I can't even quite do it. While giving you a full understanding of the biomechanics of the hand would be interesting, it's too lengthy to go into here and probably you'd be bored. Basically, the thumb moves in a sweeping range, called extension and flexion, or I hope that's how you pronounce it, not from the point where it connects to the rest of your hand, but at the carpometacarpal joint way down by your wrist. The other joints in your thumb let it bend towards the screen, but provide no extra sweep motion, and it doesn't stretch. The thumb is your hand's strongest digit, so using the thumb to tap means holding the handset with your weaker fingers. Your finger's limited range of motion and reduced strength seems to result in the use of a second hand for cradling the device. Plus, in any case where users may encounter or expect jostling or vibration, they tend to do that same, cradle the device using one hand just to hold it, securing the device with their non-tapping thumb. This is one reason larger phones aren't a disability. Thumb reach isn't really a thing, because people shift their grip as needed, among all these methods of holding. But now we're starting to get into effects, so let's stop talking about hardware and history and physiology. Just understand these 10 user behaviors and the accompanying guidelines to make your designs work for touch and people in the real world. It's easy to make assumptions and confuse empathy with your own point of view. Your users are not like you or your friends, and neither are you. As I said, we're bad at observing ourselves. Never trust surveys when you can get observations instead. So I said we have a lot of information on how people really hold and touch. The main thing we know is that people hold phones in multiple ways. But they shift their grip to reach other areas with another finger, to type with two thumbs, to cradle the device for more reach. They hold phones in multiple ways, depending on their device, their needs, and their context. And they do it without knowing, which also means you can't observe yourself well enough to predict that anyway. 75% of users only touch the screen with one thumb, but that can be a misleading piece of data, because fewer than half of those hold the phone with one hand also, and that's for phones, much less for phablets and tablets, of course. 36% cradle the device, using a second hand for reach or stability, and fully 10% simply hold it in one hand and tap with a finger, giving a totally different interaction. While you're here, other data I get asked about. Portrait, 60%, landscape, 40%, but that's for all device classes together. Tablets are used much more in landscape. 65% of the time a 10-inch tablet is used, it's in landscape. I still design everything to work in all orientations on all devices. 84% touch the screen with their right hand. Not nearly enough to assume all users use their right hand, so design for both. And the distribution doesn't match the percentage of left-handers in the population, which is confusing and I can't make sense of that. Most people observed also switch hands a lot during a single session. Age, sex, and religion? No perceptible changes, but there's insufficient data gathered to say there's not some preference buried in there. So, design for multiple contexts and for switching between them. Don't assume anything, any way of holding, any handedness, anything. And don't try to force your users into whatever one method you've decided on. Because the more I watch people, the more I'm amazed at how variable their interactions are. How they're comfortable changing their hand position. How they touch the screen in different ways to do different things with their devices as they change tasks and context. Much of the data I've gathered allows us to chart these use patterns, like I already showed you. We're starting to understand how the way people hold devices changes by context. So hardly anyone holds their phone like this unless they're typing, when it jumps up to 41% of uses. Eventually, I hope we'll get more information like this and can make design decisions based on input type and user context that you have in your app or site at the moment. So, design for every user, for the variable ways they work with their devices, whichever device they choose to use. Users, in general, for every portable touchscreen device, prefer to touch the center of the screen. We keep reconfirming this. What you're seeing now is the actual data from one of my studies. These are the actual tap positions when users selected items from a full-screen scrolling list. They naturally moved the content to the position they could tap, then I recorded the position. This also reflects other data on tap accuracy and preference we'll talk about later. When you account for content position in different devices, you find that most taps are in about the center half of the page. If you wonder about tablets, they're surprisingly similar, so that data is actually embedded into this data visualization. So you might think when you copy the UI for something like this, the key controls are the actions and input at the top and bottom of the viewport. But in fact, the primary content and interactive area is the middle of the page. All these content-centric tools are already based around the user's primary behavior of viewing and tapping the center of the viewport. The other functions are actually secondary options. This is another example of another way to get controls to the center. You can bring the functional buttons off the edges towards the middle of the screen, as Android Material Design allows you to. The directions and center buttons here are no longer hidden along the very edge, or in sub-menu. If that's not enough for you, we keep getting new research to prove it out. This October 2014 study by Mikkel Schmidt is one of the time to tap on various little squares on an iPhone 5 screen while holding with one hand, tapping with the thumb only. And look, even the center is faster, corners are worse, and there's no indication of sweep ranges again here. Because it's time to tap accurately, not to first tap, and people were indeed observed missing and retrying, it also shows accuracy by zones. We'll talk more about that in a little while. Even though it seems to be subconscious, or maybe it's learned, users prefer to touch the center of the page, and will do so when given a choice. Place key actions in the middle half to 2/3 of the screen, and place options and secondary paths along the top and bottom of the screen. Don't worry about how far you can reach with one hand, even on bigger phones and tablets. People will shift their grip to reach the secondary actions along the edges and even in the far corner without complaint. Conveniently, this extends to viewing as well. Follow the existing, reliable mobile pattern of list views or grid views. Put your main content and interaction in the middle of the page. Make sure menu bars, tabs, and status displays and action items on the top and bottom are secondary functions. If you have content that scrolls or takes up the whole page, and of course we all do, make sure the bottom of your scrolling articles and forms are padded so users can bring the last line of text or that last field towards the middle of the page. Otherwise, they still sit there trying and waste time, then are that little bit more dissatisfied with you. And avoid this trendy way of showing pages that fit to the viewport and snap to the page, so you can't really scroll. People don't read like that. So even if it isn't tappable, make sure key content is in the middle of the page. Sometimes this means providing extra room or other provisions to let users scroll longer content to the middle of the viewport. I said earlier, briefly, finger size doesn't matter, and it's true, but only for touch target size and touch accuracy. Fingers are opaque. They do get in the way. This is anecdotal, but I've seen similar results on real projects. When I updated Twitter a while ago, I kept hitting the add person icon. Not just because I focused on the middle first, not just because that icon has got this very inviting plus, but mostly because the compose area down here is obscured by my thumb as I naturally scroll through the content. I simply missed it while glancing around at the actual tweets in the middle of the page. So where are our fingers on the screen? Well, it depends on what we do and how we grasp. It's hard to say now not to place items below or to the side. You need to simply provide room around the content wherever you are. Room to make sure that you can see the target, see the label, and see the clicked state when the target is selected. When you click a whole row, and especially one multiple lines long like this, that works great. Little icons like the retweet here are too small, so the user can't accurately target them, can't confirm which one he selected, and can't see that the selected state changed on tap. You can't be sure whether you tapped at all. In some contexts, we know even better what users do. For example, this is where people scroll. Interesting, but why these three distinct areas? Because they have to do with what content is being displayed. Here, the content is a list with very small amounts of information, so there are large blank areas in the middle of the screen. Users prefer to touch the center, as we said. Get used to that coming up over and over again. All other things being equal, people want to look and touch the center of the screen. Yes, there are outliers, and I included all the data, but most users are gesturing in the middle. And here, where there were fairly long pieces of content occupying much of the screen width, users did most of their scrolling to the far right. Even left-handed users were more inclined to avoid touching the content, so reached across the screen. Someone has since shared with me they have similar observations with Arabic language apps they build, just flipped. Blank spaces to the left are used for gesturing. Users are not always confident scrolling in areas where there are items or content they want to see or worry they'll interact with. When the page is simply full of content there is no room, they choose to scroll to the far right, or left for Arabic and Hebrew, or near the bottom. Yes, this varies a bit based on device size. On tablets, your content might be shorter, so there's more room. I normalized the data to the handset so you could compare it more directly here. You might think users would stick to the edges on tablets because they're bigger. Of course, people can't reach the center, but you'd be wrong. They're always inclined to tap the center of the screen, so when room is available to confidently scroll without covering content, they'll move their finger, thumb, or stylus over there, even if it's a reach or requires repositioning their finger or their device. Make sure people can see content around their fingers and thumbs. Make sure selectable items are large enough to clearly indicate when a tap is successful. Try to place functions and the content that changes so users can see the results or to invite them to perform actions you think are important. And think about what users are clicking or scrolling on. White space may be really important to give them confidence to gesture. Stop saying fragmentation as though it's bad. Respect user choice. Devices are different because people's needs are different, and this is reflected in the way devices are used. We all think of our typical smartphone being held around 12 inches or 30 centimeters. But phablets, and something like half of smartphones now sold have screens over 5 inches, are used a little more when sitting down. And tablets are used almost 2/3 of the time in a stand or set down on tables. Large tablets, like 10-inch iPads, are used about 1/4 of the time with physical keyboards, with the screen at almost arm's reach away, and almost 10% with pen styluses. Yeah, that's a pen hiding under the case. In general, the smaller the device is, the more it's used on the move. Now, on the move doesn't mean in buses or on trains or walking on the street. It can just mean when you walk around the house or office. Instead of finding time to stop and use that tablet on a table, or sitting and typing on a computer at your desk. And as devices get larger, they're used less and less held in the hand. Distance from the eye can be surmised by device class. That's critical partly because we don't view anything based on size, but on resolution at our eyeballs. The relationship between these two is called angular resolution, which we can calculate. This is actually the simple version of the formula. To get to that 3,438 number requires knowing the wavelength of visible light and the size of the sensors in your eyeball. Don't worry about the calculations though, I've done the math for you. So the larger devices get, the further away from the eye they're used. Small handsets are held very close to the eye, larger ones in phablets further away, and tablets at approximately desktop distance, since so many are in stands with keyboards. Minimum text sizes vary from 4 point for small handsets to 10 points for devices set on tables or in stands. Yes, this really depends on the actual context, but we can make pretty good guesses based on device class. These are minimums. You go at least 30% larger for almost all actual uses like buddy copy, even larger for more readability, for active environments, and for older populations. Icons and other elements follow these same scale rules and can roughly follow about these actual sizes. They have the same concerns of readability as text. Let's dive into type a little more while we're here. Beyond sizes, the other critical thing is not which typeface or anything, but contrast. I like to pretend mobiles are used 100% by people with color vision issues, colorblindness, nearsightedness, etc. This way we have to use the best of the WCAG recommendations, the AAA standard. If these seem stringent and difficult, they're not. I use mostly white on black, which is 23:1 contrast ratio. By the way, I do black backgrounds to reduce total light output when I can, but keep the contrast up. The brand of your app or site matters, so this may not work for you. But back to sizes. I told you the minimum size in that chart a couple of slides ago, and said you should use those rarely. These are the sizes I suggest as your baseline for normal text. I really do use the minimums for labels under icons and captions and so on. The basic content size is good for normal descriptive text and is quite readable. The enhanced content is for bigger intro text, key values, and subtitles. You can add to that with a whole hierarchy of sizes as shown. If you only need one headline size, for example, which I often find I do, you skip the H1 and H2 shown here. Your title is the H3 size. This is just a guideline. You can work further off of it. Support all input types, especially if you're building responsive websites or expect to make an app for tablet and handset. If you can, get data on how your users work in their actual environment. But for most users, the patterns I outlined are pretty safe, and you can predict size and use by device class. Account for distance by adjusting the sizes of readable items like type, icons, text fields, checkboxes, and buttons. People are never going to be able to precisely click your target. There's always an accuracy, but you can account for it in your design. You remember how we discussed earlier that touch doesn't know how big your finger is, and it just gets a point at the center of where you touched. Well, that point is never ever perfectly aligned. There's no such thing as perfect accuracy, so the user misses a little, always. Accuracy is relative, and we define it with the circular error of probability, or CEP, which is just a mathematical representation of how much you miss a target. Here I use the R95 measure, or the radius containing 95% of taps. When everything is imprecise, we stop calling these errors and refer to tolerances instead. We need to plan for imprecision and problems as part of the process. Just be sure to provide the largest practical touch targets. Don't just code the word or icon as a link, but like this phone-based payment scheme, use a natural boundaries in your design, boxes, buttons, and whole rows, as the selectable or linked area. Tap anywhere nearby and you hit the target. Look around and you'll see this is a known best practice. The Google Drawer menu isn't as small as it appears with just the little arrow or menu icon. A default implementation also opens it on selecting the branding, so it's much easier to tap than it appears. Lots of hybrid apps don't notice this and code it wrong. And Android messed this up for a while and doesn't automatically bind the two anymore, so don't make their mistakes and forget good best practices when they occur. So far I've covered a lot of stuff about touch, and I've talked about it all individually, but it's really all happening right on top of each other. Try not to be confused by all the words I'm throwing out, especially when they're things like centroid or CEP. I already mentioned in a previous section how fingers and thumbs get in the way. Remember that real users work with your touch interface in the real world. Make touch targets as large as possible using entire containers such as rows, boxes, and buttons, not just the icon or word. It's a label. Don't design in the little details or retrofit touch to your design. Make your design touch-centric at the grid and template level to provide enough room and the right kind of interactivity. Touch isn't just inaccurate, but it's inconsistently inaccurate. And what's most interesting is that the largest variable is not environmental conditions, familiarity with touchscreens, or anything. It's the position on the screen that you're trying to tap. This is a chart of the accuracy of touch on various devices, aggregated over very large numbers of individuals. Black is more accurate. So now we know how accurate people are and how it varies by section of the screen. We know that people are more accurate in the middle of the screen. Hey, there's the middle again. And we mean pretty much any screen, any way they hold their phone or tablet. They also subconsciously know this, or it may be tied to that preference for reading in the middle, so are more confident at the center of the screen, and will slow down to tap corner and edge targets. If we map that same research differently, we can see how much more room is needed between items in various parts of the screen. The sides are a little worse than the center, but the top and bottom require much more room, and corners are just the worst. I see these actually neatly correspond to sort of structural zones that already exist in much of our design. Think of the rows you already designed to, with mastheads, tabs, the big content area in the middle, and the chyron at the bottom. So design by zones, spacing selectable items to prevent interference based on how well people touch parts of the screen. You can almost get away with simply calling this tip avoid the corners instead. Edges and corners have less accuracy. When putting items here, space them further apart and use fewer tabs or menu bar items. The sides are also a bit worse, so avoid actions that take place only at the left end of a list. Take advantage of the natural middle selection preference and improved accuracy there. Whether you check digitally or, as I'll show later with real-world tools, you measure space between centers. Center the size target in the tappable area, and if anything else is in the circle, that has a chance of being tapped by accident. So those top icons are a bit too close together, and the tabs are far too short, so you can tap the action buttons or a tweet by accident. The icons in the middle of the page are small, but most important is that missing them selects the tweet reviewing. This is good, it's a tactic. If interference is likely, design for resilience so the user can make do, but certainly never so there's an unrecoverable condition. Email format controls, for example, should never be right next to the send button because send is unrecoverable. Once you've accounted for interference, you want to design to not annoy. Things like this, where you try to click the link and instead open the reply dialog, are not catastrophe, but they could be better. There hasn't been much data on how we use tablets, till now. I, for one, went out and got my own as part of this latest round of research, and was able to confirm that these same pointing accuracy levels apply to 7, 8, and 10-inch tablets as well. Click most accurately in the center, a little less well along the side, well along the top and bottom of the screen, and especially in the corners. This test app was hybrid with the default target sizes. That meant many users couldn't select the menus on handsets or tablets as a result. So design by zones, spacing selectable items to prevent interference based on how well people touch parts of the screen. Remember, the sides are less accurate than the centers, so if you use lists, avoid things like delete or select being only along the left or right side. If you have to do this, pick your vertical list spacing from the side accuracy level. When you do put things in the middle and follow these guidelines strictly, you can get away with quite dense information, whether it's closely spaced lists or small selectable areas in any layout. When you place controls along the top or bottom, use as few items as possible and space them out. The Android action button spacing recommended by them is too tight, so loosen it up. And more than 4 items in an iOS menu bar, at least on their smaller phones, is asking for trouble. Remember to plan for interference and space unrecoverable or annoying to exit items far from others, to provide undo features, and so forth. I still get clients asking for Easter egg level hidden gestures, with the theory being that users have to explore your app to find the neat features. Sure, if you want to, but start with what works. Simple controls that work in expected ways. and the most expected controls are those that are visible and communicate what they do. Make sure selectable items are clearly selectable. I haven't done a study specifically about this, but I'm seeing enough observations on other user research and for usability studies for clients, I'm comfortable saying what should seem obvious. If it doesn't look clickable, people don't know it's clickable. Underlines, for example, aren't bad for text in line, but especially for apps, you mostly need to bound items. That doesn't mean everything has to be inside a bold box or a default style button. Here, translucent backgrounds on the menu and controls, and a sort of circular tab strip around the center, suffice to define them clearly as functions. I'm also starting to see that any bound item is considered selectable. If a visual designer had boxed the title elements for visual consistency, people would assume they can tap it to get more details. As it is, it's better. It's differentiated by a distinct style, combined with a few typical icons like play that clearly say these are clickable, others are not. Clickable items need to not just afford their action, making it clear what they do, but to do so consistently. I want somebody to tell me why my calendar name, attendance, and the participants are selectable rows, but the location is a link, and I have to click exactly where the link is. Be consistent, and like I just said, make whole contained areas, whole rows and boxes selectable. That's what people expect. Visual targets, whether words, icons, or some other shape or UI widget, must attract the user's eye. Be drawn so that the user understands that they are actionable elements. Be readable so the user understands what action they will perform. And be large and clear enough the user is confident he can easily tap them. Follow the size rules I already showed you per device class. For years, I used to think people needed explicit notes of clickability. But sometimes arrows to the right of each line don't help. Sometimes they hurt. Sometimes things like whole rows are inherently selectable feeling. Test with your users, but otherwise work with that. If you use gestures that involve dragging from off-screen, or even just targets right against the edge of the screen, you might be forgetting about raised bezels. Phones are flat, right? Well, no. Plenty have a raised bezel to protect the screen, and many users put cases on. What this means is many users cannot actually get to the edge of the screen. If they really press their finger, they can get skin onto the edge, but remember the screen senses the center of your contact area. It's going to think the user is touching around here somewhere instead. Avoid edge gestures or provide plenty of padding so they work for all users with a case. Remember that people use their phone in real environments and interact with them just as they do with anything else. We can't think that people just interact with a flat glass screen. People shift the way they hold and touch their devices depending on the device, the input that is necessary, the position of the screen they're trying to tap, and their context. But what context? Aside from on screen, I observe people changing the way they hold their phone when opening a door, carrying groceries, holding a baby, walking down the street, walking in difficult terrain or stepping off a curb, riding on a train or bus, especially when standing, or when in dangerous contexts such as walking in the wind or near water or a drop-off. People adapt to their situations, but they do suffer consequences. Simply carrying a bag of groceries reduces accuracy in quite shocking ways. Recent research has explored the effect of trying to carry other objects while walking and using the phone. Just carrying a shopping bag in the other hand while using the phone with one can reduce touch accuracy in the most distant corner to the screen by over 30 millimeters. Remember, I argue for 10 to 14 millimeter targets. Others say 7 or 9. 30 millimeters is a lot. People missing targets by factor of 6 has not even occurred to us before this. If you want to place items right against the edges or have edge gestures, go ahead, but don't only allow them to work at 1 pixel from the edge or originating off screen. Provide some padding. The safe zone here is somewhere between half and the full width of the accuracy by zone. Along the sides, I use 6 to 8 millimeters. For the top and bottom, I would expand it to about 10 to 12 millimeters. If important to your product, test with the most intrusive case you can find. Always consider contexts. Think about how your users are likely to actually work with their phone, and think about how bad your app will work in a worst-case scenario. Size guidelines are fine, but you can help yourself a lot and reduce your math by just checking your work at scale. Take the design out of Graphel, Visio, Axure, Photoshop, InDesign, whatever you use. Get it off the computer. There's no need for clever prototype tools, though things like Get Launch or PopApp do work well. Just put screens into the device gallery. Draw on paper. Put your designs on the phone whenever you can. Carry the phone outside and actually tap on the screen. How it works and looks on the real device is very different from how it looks in Photoshop on your computer. When ideating, bring device templates and devices, so everyone can not just wave their arms and scribble on the whiteboard, but try out your product and others right there. Sketch a device scale, so you start with it being the right size. Avoid too much reliance on your computer screen and on PowerPoint to show it off. Try it out. Pass it around the room to make sure you aren't foolish, and to share the design the way it will really work in meetings with clients or stakeholders. Visit or simulate real environments. Here we drove down the street to a store where there were trial kiosks with iPads. Later it was something else, so this was effectively a prototype. People using your tool in trucks, in auto repair shops, in mines in Brazil or village clinics in Africa. You can't really tell how it will work from your cubicle in the financial district or a usability lab. When it comes time to measure and confirm sizes are correct, do it directly on the device to make sure your sizes are right and you didn't mess up the math. You can use any circle template from the art supply store, or I guess these days Amazon, but I made up my own little tool I keep in my pocket because this is so important. You can get the template and see video about how to use it and why at forth.com/tt, or touch template. Disappointingly, we can't solve all this as app and web designers and developers. There are scale issues involving the way that device-independent pixels and viewport scaling works. The key issue is that OS makers and device manufacturers hear nothing but your cries of fragmentation and try to simplify to as few scales as possible. Unfortunately, that means they lie. They group items into a fairly small number of categories. Yes, even Apple. Maybe especially Apple, as there's no good way around the in-device scaling of the iPad mini or iPhone 6 Plus. Even if Google, or Apple, gave you good size specs, the variability in scale between devices means your text, icon, or touch target could be a bit larger or quite a bit smaller than you planned on. So for example, you make a button 7mm tall to assure people can click it and nothing else. Set it to the correct size in device-independent pixels, and when it gets on real phones, it's as small as 5mm. That's often going to be intolerable. Bringing your intended sizes far below useful or so large nothing ends up fitting on the screen. Paper continues to be the best way to design and keeps being our friend by working at any scale we want. Try out your work on real devices as soon and as often as possible. It doesn't have to be real code. Take a photo of the whiteboard, crop it, and stick it on the phone. Does it make sense? Plan to design everything about 20% larger to account for undersized targets and type. This is often safe anyway. I sometimes say 30% larger for users in worse environments with bad eyesight, etc. Look at the devices your users actually have. Do the math to find out how bad it is and adjust a bit for follow-on releases if it's a problem. It seems like a lot when you see this all on a list, but just remember the core features of these 10 points. Put content and functions in the middle of the screen. Design with fingers in mind so users can see around them. Design by zones, with bigger touch targets along the edges and corners. Place touch items to avoid catastrophe when people miss targets. Be consistent in how you design interfaces and interactions. And always respect people, their device choices, their patterns of use, and their contexts. Within what you control, just always remember to design for hands, fingers, thumbs, and people. For a summary version of this deck, all the articles I've written and referenced, check out forth.com/touch. And thanks to my friends at ZipGun for some of the software development work, usertesting.com for donating services to the cause, and the eLearning Guild and Patty Shanka specifically for giving me access to a bunch of researchers and helping me with analysis I wouldn't have otherwise been able to do.